Hello, YouTube. This is Umel03. For many videos, we've been talking about data structures, right? For most of the Python videos in this curriculum, we've been using lists, and then a little bit more recently, we talked about tuples and sets and dictionaries. And a lot more recently than that, we talked about stacks and queues. And we've also really brought up this notion of having other data structures and being able to convert from one to another. When is it that you'd want to use a tuple, and what is it that you can do with tuples? When is it that you'd want to use a queue, and what is it that you can do with queues, and how would you convert from a list to a set, for example, or from a dictionary to a tuple, and what does that operation look like, and why would you do it? But we said that for any data structure can have mixed data types in it, right? You could feed tuples and booleans into, or you could feed ints and booleans into the same tuple, right? You could feed lists and strings into the same tuple, right? You can have basically data structures within other data structures, and you can mix and match data types pretty much as freely as you'd like to, right? And then we can also have a length of a data structure, right? So any data structure will have a length that's represented by an integer that's greater than or equal to 0, right? So you could say length of tuple or length of dictionary. You could also have the length of a stack or a queue, right? Because remember, in our 2 YouTube videos about stacks and queues, we created classes for them. We had to go ahead and create and define what a stack is, right? And we implemented it with a list, right? If I scroll down, we have a class stack, right? We defined a class stack. And it basically says self.items is equal to an empty list. This is what happens when a stack is created. But the point is that we can have the length of a stack because we know the length of a list, and a stack is implemented using a list. So hopefully that's clear to you. And then for any data structure, we can also see whether an element exists within that data structure, within that iterable. And the keyword that we use for that is in, right? So we could see whether a character is in a string. We could see whether an element is in a set. We could see whether a unique key is in a dictionary, right? If you say print W in my dictionary, it returns true if W is one of the keys in the dictionary, right? But if you wanted to see if a value exists within the dictionary, it wouldn't be enough to say, W in D, where D is your dictionary. You'd have to say W in D dot values, right? You'd be looking to see if W is one of the values. But anyway, we can see some different operations, and if anything is unclear to you about lists, tuples, sets, or dictionaries, I would highly encourage you to go back to lesson 57 and take a look at the examples that we have. Remember, we created like a try list function and a try tuple function and a try set function and a try string function to go ahead and just make sure that we were familiar with some of that functionality. But what we're going to do is we're going to look again at this try string method. I want to review this one more time. So I'm just printing, on line 302, I call try string. And so we can basically get a sense of what this method does, right? We have butter and fly. These are 2 strings that are being created on lines 246 and 247. And then on line 248, we say that we want to concatenate the result of word1.lower with the result of word2.lower. And so that would basically give you the lowercase versions of those 2 words combined into one another, right? And then if we say word1.count of capital T, that gives 0 because there's 0 capital T's on the word butter, right? But if you say word2.index of dot, that would give you 1 because the first time that a dot occurs in f.l.y is at index position 1. And then if you say print word1 of 0, remember we can access strings as if they were lists that had index positions. So word1 of 0, that would give you the capital B because that's the character at index position 0 within the string. And then if you say print of tuple of word2, that would give you basically a tuple with the elements being the characters within f.l.y. So there are 5 elements because there are 5 characters in that string, but it's a tuple, right? And then if you say print of word1 dot replace of T comma F, that would, instead of getting butter, you would get buffer because it just returns another string where all occurrences of T are replaced with occurrences of F. And then there's start ends with and starts with. So word2 dot ends with of Y, that gives true, but word1 dot starts with of but gives false because but here starts with a capital B, but in our word1, we were starting with so we were asking to see if it starts with a lowercase b, right, and but our word starts with a capital B and butter, right? And then what I also wanted to talk about is the split and join. Remember, so if we say print of string to list : equals word2 dot split of dot, Basically, if we take a string and we call dot split of, and then we pass in some separator, it returns a list where all the elements are sort of separated by the separator that we indicated, right? And word2 has dots in it, so it's going to be able to create elements that are separated by those dots. And so it would give us 3 elements in total, right? And so we get FLY, and it comes in a list, right? So it's a list of 3 elements because there are 3 separations, you know, on those sides of the dot, right? And then if you say print, and then what if you say back to string equals dot join of string to list, right? So this dot in quotes is your separator, and then this dot is like calling the join function on the separator. So you call it on a separator and you pass in a list. And so basically what it's going to do is it's going to form a string based on a list. So it's like the opposite of split. But if you try to assert that word2 equals back to string, right? So basically we said that the assert that will allow the program to keep running if the Boolean is true, and it'll throw an assertion error if the Boolean's not true. So do we have an assertion error here? No, it looks like we don't, because this, you know, this string that we formed as a result of joining the list that was formed by splitting up the string is the same as the string that we started with, right? And so we just get f.l.y with a capital F. It's the same thing. And we're using a format function here, right? We say xw.format of, and then we say x equals original string. You know, the word's original string concatenated with whatever word2 is, right? And it's equal to the string that we started with. So hopefully that's clear to you. And then we can also talk about stacks, right? So we talked pretty briefly about stacks in previous videos, but we create a stack class, right? And there's some operations that you want to be familiar with. Remember, it's a last in, first out operation, right? It's like a stack of dinner plates. But you say my stack equals stack. So we initialize an instance of the stack class on line 268. And we've already talked about a stack class, but I have it here, right? On line 172, we sort of begin this class definition, right? And there's a constructor where we create an empty list. That's the list that our stack is going to be based on, that our stack is going to be implemented by, right? And then if you define is empty of self, that would just return true if the length of the list is 0, right? And then you can push elements onto the top of the stack, and you could remove elements from the top of the stack using pop of self, right? So if you say, for example, for some stack S, if you say print of s.pop, that would return the top element of the stack, but then that element would no longer be the top because it's going to be removed from the stack. And that's different from peek of self, right? If you just call peek, that would just return the top of the stack without removing it. And then you can also print stack, so it's a void method, it doesn't return anything, but for some stack S, if you call s.print stack, it would return, you know, it would print the elements in the stack one at a time, right? And you would be printing the top of the stack first, and then you would be printing the bottom of the stack later on. But the point is that the freshest or the newest elements would be at the top, right? The last in is the first out. It's not at all like a supermarket or a line at a grocery store, right? That would be a queue. Okay, and so we can also talk about a queue class, right? And we have a pretty similar constructor here. We create an empty list when the queue is created. And we say is empty of self. Well, that returns true if the length of the items list is equal to 0. And we can push items onto the queue. We can pop items from the queue, and we can peek at the front of the queue. But you want to think about a supermarket where it's like if we add an element onto the end of the queue, onto the back of the queue, it's going to be a while before we peek at it, before we're able to pop it off, especially if there are a lot of people before that person, right? If there's already a lot of elements that were added into the queue before that newest element was added into the queue, right? And we can also print the queue. We just say for element and self.items print of element. And we can go ahead and try this out. So we can have a stack where we say my stack equals stack, my stack.push of sup, my stack.push of 72, my stack.push of 5 in the set in this dictionary, right? So it looks like this is a little dictionary here, and it looks like it maps the key 3 to the value 5. And so the question is 5 in this dictionary? And so this would actually give a false Boolean because 5 is not a key in the dictionary, right? But if you said s.values for some dictionary S, then that would return true. So hopefully that's clear to you. And then you can also push a string, right? So we can also, there's a lot of different data types that we're pushing onto the stack, right? But you could print the length of the number of items in the stack. Number of items in the stack is what would be printed by line 275. And you could also see if the stack is empty, right? And then you could also say for u in range of 5, print of my stack.peak. And so that would just print the top of the stack over and over again without removing it, right? And that's why we would print, so peaking does not remove the element. And then you could say, while not my stack.isEmpty, print of my stack.pop. And that's the difference between peak and pop, is are we just going to look at the top of the stack, or are we going to return and remove the top of the stack? So hopefully that's clear to you. And then we could say stack to set equals set of my stack.item. So we're going to get the set representation of the list that implemented the stack, right? It's just going to be the unique elements within the stack. And so if you say print of length of stack to set, well, if all the elements were unique, then the length of the set should be the same as the length of the stack was originally. But it looks like we were pushing 72 a couple times, right? So presumably this stack to set would have a smaller length, a smaller number of unique elements than the number of potentially duplicate elements that the stack is based on, right? So it looks like popping removed elements from the stack. So the created set is empty, right? Here, there's actually not going to be any elements in this set, because we already popped the elements out of the stack. But we can go ahead and try all this functionality, right? I just want to show this to you pretty briefly, right? So we could say try stack. Okay, and so just let's see what happens here. So what all happens? So we said 6, that would be the length of the stack, right? We pushed 6 elements onto it, so that's why you get a 6. And then the stack is not empty, right? But then we peaked at the top element 5 times, and that's why you get 5 72s. But then if you say for you, and so then if you say, so peaking does not remove the element, but then we go ahead and pop the elements off the stack, right? So 72 is the most recently added, so it'll be the quickest removed, right? And then 12, and then October, and then false, and then 72, and then sup. So hopefully that's clear to you. And then the length of this set that was created on 283 is 0, right? Because we already popped the elements off of the stack, and so the created set would be empty. What about for Q? So you could say my Q equals Q, and then my, it's just a constructor that doesn't accept any arguments. It's just sort of an empty constructor. We start with an empty Q. My Q.push of Andrea, my Q.push of Linda, my Q.push of false. So putting a Boolean onto the Q. And then my Q.push of 529. So you can put a list of ints onto the Q, a list of anything onto the Q. And then you could say, let's start serving the customers in this queue by how they showed up. And so if you say for T and range of length of my Q.items, print of my Q.pop, okay? And so basically that would just keep popping elements off of the queue. And then we would say print float of length of my Q.items is greater than 0. Well, length of my Q.items is greater than 0 is a Boolean. That's either going to be true or false. And we said float of a true Boolean is 1.0. Float of a false Boolean is 0.0, but we'll see one or the other. And hopefully you can already make a prediction about which of those two numbers, 0.0 or 1.0, we're going to get at the end of the function call. We get 0.0, but it goes ahead and prints the elements in the queue in the order that they appeared, right? That's how a queue works, and that's how it's different from a stack. So you would print Andrea first, and then Linda, and then false, and then the 529, right? That's the next element in the queue is this list. But then you could just say 0.0 because eventually the length of my Q.items is no longer greater than 0, right? That queue would be empty after you popped the elements out of it. What we're going to do now is we're going to talk about something called a frozen set. And so basically what you have to know about a frozen set is it's essentially a set that you cannot add or remove elements from. So in the previous video, we drew some distinctions between tuples and sets, right? We said there are a couple of differences between tuples and sets. The first one, obviously, is that with tuples, you can't add or remove elements, right? Sets, you can add and remove elements as long as they're unique, right? So if you added the number 82 to a set 275 times, you could go ahead and do that 275 times, but it's only going to appear in the set exactly one time, right? And then if you remove it, it's gone. But every element that you can think of in the whole world is going to exist in the set either 0 time or 1 time. That's it. With a set, we can add or remove elements, but also with tuples, elements are accessed by index position. Sets, elements are not accessed by index position, right? We don't characteristically think of sets as being ordered, right? This set, it's sort of just a collection of unique elements. But with a frozen set, basically what we can do is we can think about a set that you cannot add or remove elements from. And the way that you're going to create it is you can say A equals frozen set of some iterable. So presumably you would be starting with some iterable, but we can basically go ahead and try it and figure out how this works. So you can say A equals frozen set of 5, 2, and 9, I think you can probably, you would have to go ahead and pass in some iterable, right? So start with an iterable. Start with, you know, a list, tuple, set, or dictionary. I think those are probably the operations that you could have. You might be able to start with a string too, but we can start with a couple of examples, right? So you could say my list equals 4, 3, 4, sup, nothing, right? And so here there's going to be one duplicate element, right? We see a couple of 4s, but then what we can do is we can basically say my frozen set equals frozen set of my list. Okay, and so I basically want to basically show you what that would look like, right? And we probably could have done both of these lines in one line using the walrus operator, but that's okay, right? We can go ahead and run main.py and we see frozen set of sup, 3, 4, and nothing. And so you can see it's a set where basically the duplicate 4 got removed, okay? So basically, you know, just like with regular sets, frozen sets do not hold duplicate elements, right? They can only hold unique elements. But now what we're going to do is we're going to try something. So we're going to say my frozen set dot add of 10, because remember with sets, you know, with sets in general, we're able to add elements, right? It's just that we can't have duplicate elements. But with frozen sets, the point to drive home is that with frozen sets, you cannot add or remove elements at all. It's a set that's set in stone, right? It's like a list is to a tuple as a set is to a frozen set, right? It's basically an immutable version of the same data structure. And then you could say something like, I don't actually know what error that would throw, but we could say something like, let's just try my frozen set.add of 10 and figure out what Python error we would get. We would get an attribute error, right? So it's basically trying to do something with a data structure that we can't do with that particular data structure. So we could say try my frozen set.add of 10, and then we could say except attribute error. We could say print cannot add elements to a frozen set. And so we're just seeing examples of that right now, right? And so hopefully that makes sense to you. But then we could go ahead and run, and then it would just say cannot add elements to a frozen set, right? What if you tried removing an element? So what if you tried removing s concatenated with up, right? We can see sup as one of the elements in the frozen set. But then, you know, there's no remove operation that's defined for a frozen set. So hopefully that's clear to you. But with frozen sets, you can also see if a frozen set is a subset or a superset of another set, right? Remember with sets in general, we could see if a set is a subset or a superset of another set, right? And we could also do set1.union of set2, and that would return another set with the collection of all elements that belong to at least one of set1 and set2. And then if you say set1.intersection of set2, it returns another set with the collection of all elements that belong to both sets1 and sets 1 and 2 uniquely. But anyway, you can do the same thing with frozen sets. So if you say for some frozen set f, if you say f.intersection of g, that returns a frozen set with all unique elements that exist in both f and g. Okay, if you say f dot is superset of g, that returns true if all elements of g exist in f, and false otherwise. Okay, but the g can be a set or a frozen set. But the point is, if you call it frozen set.union of any set, whether it's frozen or not, the result is a frozen set. Okay, and you can also convert a frozen set to a list, a tuple, or a set. So I want to just show you a quick example, right? And so here clearly we can't do that, right? But then we could say print tuple of my frozen set. So you could always just go ahead and convert a frozen set to another data structure, right? And so now you would have a tuple, right? And then you could say b colon equals tuple of this, right? And then you could go ahead and access elements by index position. So hopefully that's clear to you, right? And then you could just get you could get b of 0 would just be the word nothing, right? So hopefully that's clear to you. But then you could also see, so my set 1 equals 9, 2, 3, right? And so what if you say print of my frozen set dot intersection of my set? So just like you can have the intersection of a set with another set, you can also have the intersection of a frozen set with another set, okay? And that other set, the other set that you're passing in, it can be a frozen set or a set, okay? But if the main set that you're calling union or intersection on is a regular set, this method returns a regular set. If the main set that you're calling union or intersection on is a frozen set, you're going to get a frozen set, right? So if you say dot union of my set, this is a regular set. It's not a frozen set, but returned is still a frozen set. So hopefully that's clear to you. But then what if you had said my set 1 dot union of my frozen set? So now we're going to say regular set.union of frozen set, and now we can see the data type of the set that appears. And so this is actually going to be a regular set rather than a frozen set. And so hopefully that's clear to you, and we can see some more examples and do some more functionality with frozen sets in the next video. But at least I got a chance to introduce the data types, introduce the data structure. Go ahead and play around with some more examples on your own before watching the next video, but we'll just continue from here. From uMills03, thanks for watching, and please subscribe.